Hello, mentors. Suppose we have the map of California and we already selected 4 different locations. So remember, these 2 players get together, each chooses 2 locations, and just for simplicity, the bigger or interesting case where all locations are different. So what's going to happen? Let's say we have these points A and B from one player or from one student, and then B and A and B but prime, so the other points. And we want to find a place that's kind of in the center in some sense, where it's comfortable or at most or as comfortable as possible to all these people that are in these campuses in colleges to drive. So it's a common place. So one way to talk about it is using the geometric median. And you don't have to talk to your students like that. You don't have to formally define it or even say what it is, but just try to see the following. So let's say we just come up with any point that's suggested for allocation. Let's start with one that doesn't look too good, like here, this red point. So we call it P and Q. And what's going to happen is we are measuring with ruler all distances from the 4 original points to this suggested point. So players or the students could use rulers or could also use their hands and get a sense on what are these distances. And then what was going to happen is we take the sum. So we add them quickly. We can, of course, approximate a lot, and we add them quickly. Students may not have the grid, of course, but they could have the rulers. So adding is totally okay. Let me illustrate what happens here. So I'm going to call this point X, and it's going to be the sum of the distances. So here I use the formula, but in the meeting, you don't have to use this root formula. This is just for me to illustrate. So right now, it's going to be 27 units. Let's pick another point, maybe here. So what students would do is pick another point. It's trial and error, say we're getting closer maybe. Measure again quickly these 4 distances with the ruler and add them. So now we got 18. So it's getting better. Of course, students will not start here as the first approach or not here, but they will recognize that it's a quadrilateral, right? We have a shape with these 4 sides, and it should be kind of inside in a sense. So let's pick it here. And now the distance is 12. I'm just graphing it here with this green line. And so to be in fairness, I would like to minimize the sum of these distances. Okay, some would be maybe really bad luck, like this A would have to drive a lot to go to this meeting. But B wouldn't drive much. Same for A prime and B prime, maybe not so much, not so less. So a good way to measure this would be the sum, right? And we want to minimize this sum. We want to make this sum as small as possible. Think of it as cost, right? The driving cost, and then we want to have a very low cost for this. Let's pick it here. You see how when I move this closer to some center, so to speak, then this green line goes down because it's indicating the sum. So right now the sum, let's start again. Here the sum is not even in the screen. And then I move gradually, which students may not be able to do, right? They have to put these points and try, but here it's where it appears. 14, 12. Let's see, going still down. And here I enter some zone in which doesn't go down much, right? Like no matter how I move, it's between 11 and yeah, 10 point something, sorry. So almost 11. And so I'm not looking for an exact answer, but something that's, reasonable. So it could either be here or even better here. And then at some point, students, after maybe 2 or 3 trials that are good in the zone, they could pick the best one, the best that it was. So here it looks like 10 point something, right? 10.8 maybe, something like that. Here you can see it, 10.84. But what's important, it's not about the right answer. or the exact answer, but about this last graph, this star, where you have this center and you have these 4 lines or line segments. And the conceptual idea that you want to discuss with your students is we have infinitely many stars. We want the star such that these 4 legs of the star are as small as possible in sum. That's the geometric mean, the geometric median. So hope you enjoy the meeting. And in another video, we'll talk more about other ways to approach this problem. See you.